More than 500 years back, there was a fight between Socrates and Zeno. And the fight was about a simple question. Four questions were asked by Zeno to Socrates, and Socrates could not answer. And none of the questions could be answered at that point of time. Whatever the question, the question was that if at a very small, the smallest possible time, you go to the smallest possible distance, and then you can add all the tiny little discrete pieces of time to get the whole time, and then that for smallest distance where you were just static, because for some time you should be static at some place, right? So if that is so, then delta t plus delta t plus delta t plus delta t will be delta x plus delta x plus delta x plus delta x. So you get static plus static plus static plus static plus static. Total time you never moved, so motion is not possible. That was the basic idea of this, of Zeno's question, and Socrates didn't have any answer logically. 500 years later, when quantum mechanics came and uncertainty principle came, then it was told that, look, at a very small point of time, this given time, when I know that there is no momentum, you are static, then where are you located? I don't know. It could be somewhere else, here and there. You could disappear from the universe and you can reappear at any other place. So, given that logic, if quantum mechanics is true, then motion is possible. So even simple classical motion, you can't explain without quantum mechanics. Think about it. So right now, in your life, you can find you are encountering situation in which there are many critical features that you have developed about a particular concept. But when you try to make other person understand, then you don't know which one to emphasize, because the person could have a choice at many different places. Given the necessity of a particular situation, he might change his choice. He might like B and you describe about C. So if you choose a single topic, then you have always a chance of failure, that the person might be interested in one of the 30 topics that you could talk about. In all these situations, you get very, very confused. Some people, they know only one or two, they win and you get defeated just because you are not aware. Quantum mechanics could also help there. There is one term in quantum mechanics called contextuality. What is contextuality? Depending on the environment, you change your way of presentation. Quantum state changes its configurations, and the distance between different contexts, the relative distance, that's like it is used in LLM. You can redefine what you have, or your position or view about one of the 30 topics that you know. So the best thing is to put your concept following the quantum mechanics principle and try to expand it and interact, engage with the person you want to impress or you want to explain. And then, depending on how it goes, evolve a few topic or switch. And a tensor, imagine whole view is a tensor, 16 different kind of choices, and then slowly you can diagonalize the whole thing. So contextuality tells us three important things. One, path is important. Path is also an integral part of the solution. For classical, there is no analog, no classical analog for this. Path is never there. I mean, source and the destination, because of the measurement you get the final output. The path does not play a concrete role in shaping the answer. So shaping the answer is a word that you do not talk in classical. So that's why quantum easy problems, there are two types of problem: quantum easy, quantum hard. If you are considering quantum easy problem, then you need to just get one value. And in most of the cases, people try to build quantum computer or quantum technologies using quantum easy method, just one value in the diagonalize. So lots of calculation will happen in between, and finally I will get this result. This result I get very fast. So speed is the evidence that quantum information processing happened. This nobody will tell you. So this is the biggest problem of quantum computing and quantum information processing, that they say that if you check every step and every method, then it will take enormous amount of time to prove that there was at all a quantum information processing. Instead, you just check 1 plus 1 equal to 2, and then you follow the massive process, and finally you reach the final solution. And that final solution, if it is done very high speed, then it will prove that there was a quantum information processing. This is the foundation of logical quantum computing. And this, for every reason you can think that it can turn out to be fake, you cannot justify logically that at all quantum information processing happened. Because if somebody follows a simpler logic, simpler steps, then they can get the result faster, and your whole argument of quantum computing and a quantum advantage or quantum supremacy will fall apart. What you can do is always try to go for quantum hard. When you go for quantum hard, there is an advantage, and the advantage is that you provide the shape of interconnection of the problems, which almost I foresee that future is moving toward that kind of quantum. Then you will be able to see how different conditions, different kind of choices are building a pattern among themselves, which collectively projects a view, and that people could take. And if you adopt this in your philosophical principle, when you are addressing anything in your life, in your practical real life, you will always win. So this is a quantum way of winning. So you have read about many vocal tonic in YouTube. They give inspirational talk and then lots of things. Here is a prescription of quantum way of winning. Quantum way of winning is therefore build a geometric shape connecting all the possible choices and project it depending on which environment you are accommodate. And this geometric shape, critical features of this geometric shape, which you must not change, that's called invariant. If you can hold on to that, you can give any associated projection that is favorable to the person who is evaluating you. So it was started by Zeno and Socrates' debate, and I hope that LLM has put us to a situation when quantum contextuality will make the last laugh and the world will follow a very different route.